Thank you. All right, today we're going to look at congruent triangles. We're going to look at what are the properties of congruent triangle. Two triangles or two figures are congruent if all the matching angles are the same size, all the matching sides are of the same length, and matching region will have the same area. Okay, so we are now going to look at specifically congruent triangles. There are 4 tests for congruent triangles. These are SSS, SAS, AAS, and RHS. You have to remember them. Let's look at what each of these mean. SSS means all 3 sides of one triangle are respectively equal to the 3 sides of the other triangle. That's SSS. Okay, SAS means 2 sides of one and the included angle of one triangle are respectively equal to the 2 sides and the included angle of the other triangle. And AAS means 2 angles are equal, 1 sides are equal. RHS means the right angle, hypotenuse, the H has to involve the hypotenuse, is equal to the hypotenuse of the other triangle, and 1 side is equal to the other side of both right angle triangle. Okay? Okay, so these are the 4 tests. We're going to use these 4 tests on the 4 examples below. For each of the triangles below, state the congruent test used. So you just have to state what you use. So you got these 2 sides, these 2 sides, and these 2 sides. So therefore it's SSS, isn't it? All right, just write SSS. Pretty easy. Okay, how about the next one? We got 1 side, another side, and then we have this angle in between the 2 sides. What do we call that angle? Included angle. We learned that in trigonometry, SAS. Remember when we use the cosine rule? Included angle. So it must be the included angle being equal. So it's SAS. The A has to be in the middle. So that angle here has to be here. If it's not there, that will not be the right congruent test. Okay, we've got 2 more to go through. SAS. This one, we got 2 sides and 1 side and the 2 pairs of angle equal. You say AAS. Put the 2A first, then the S. And finally, we got they are both right angle, and they both have hypotenuse, and the side equal. RHS. Right angle, hypotenuse, side. Not in the context of the other topic equation, it means right hand side, but this one means right angle, hypotenuse, side. Okay. Be careful that this may not work for another pair. So if I draw it like this, if I draw 3 here, 1, would it still be RHS? No, because it doesn't use H. What test would it be? Yeah, SAS. Even though there's a right angle, because the angle is included angle. Remember, when it has an included angle, we say SAS. So note the difference. There's one more comment I have to say. Let's go back to the previous one. This SAS, is ASS a test? It's not a legal test. Now let me show you why ASS is not a test. Say I'm going to draw this. This is 5. This is say 2. We got say 30 degree. So it's like ASS, right? So you got angle, we got a side and a side. And then we're going to draw another triangle like this. 5, 2, and then 30 degrees. See, they got the same angle and 2 sides are equal, but the angle is not included, isn't it? Clearly they are not congruent. One's an obtuse angle, one's an acute angle. They both have 5 and 2, but they are not congruent. They both have 30 because the 30 is in the not a included angle. Does that make sense? That has to be in the middle. So that's not a test. Okay. Yes, has to be included. So these 2 are not congruent. Not congruent. Does that make sense? Right, good. All right. Okay, now we're going to look at, let's do a question. Let's do a practice question using congruent tests. A fully set out congruent proof involves 5 lines. The first line introduces the triangle. The next three set out the three pairs of equal sides or angle, and the final line is the conclusion. Maybe you don't need 5 lines, you just have to do 4 lines. Okay, let me show you how it works. Let us start with A. Okay, alright. Okay, so we'll try to prove triangle POM is congruent to, you may like to highlight the triangle that you're going to prove congruent, is congruent to QOM. Okay, you try to prove these two triangles are congruent, so you have to give 3 reasons. So, are the sides being equal or angles being equal? Okay, so who can give me the first thing you could see that are equal in the 2 triangles? 2 equal sides, which 2? Okay, so you just say OM is common. Okay. Yep, so you say QM equal to MP. What reason? You say given. Why is it given? Because it's labeled there, right? Anything labeled, you say it's given. Right, you say given. And Jeremy, which angle you say are equal? 2 right angles. So you say angle MQO equal to angle MPO, which is 90 degrees. That's also given as well, because it's labeled on the diagram. So you've got 3 things, and then think about which test you're going to say. So you say, right, conclusion, therefore triangle POM is congruent to triangle QOM. You have to give a congruent test. Think about which congruent test will be suitable. Alright, anyone want to contribute? Which test should we use? RHS, yep, because we got the side. Well, this is the hypotenuse, this is the side, this is the right angle, right? RHS. So the OM is the hypotenuse, and then QM is the shorter side, and then we've got the right angle, so it's RHS. Done. Okay, we can do part B. Now part B say, show that OM bisect angle AOB. What does bisect mean? Cut in 2 equal halves. So OM bisect means we have to show, if you cut in half, means you have to show angle MOP is equal to angle MOQ. So you have to show these 2 angles equal. Okay, how is that related to part A? We just proved that the triangles are congruent. So what can we conclude about the angles? They must be equal, isn't it? So you say, therefore, they are equal because you give a reason, matching angles in congruent triangles. Matching angles in congruent triangles. That's the reason you give. Because these are the 2 matching angles in the congruent triangle. They're opposite to the matching sides. See that these 2 sides are equal, therefore the 2 matching angles are equal. And because the matching angles are equal, then you can say, therefore, answer the question, OM must bisect. So you're just copying down the question again, bisect angle AOB. Right, so that's the reason you give. So very important, you write matching angles in congruent triangles. Or if you say the sides are the same, you say matching sides in congruent triangles. Okay? Alright, we've got 1 more question to go through, then we're done. Any questions? So it's pretty easy, this topic. Not very hard, there's not much algebra, so no graph, so it's pretty straightforward. Okay. So we'll go to the next one, and there's no very abstract concept involved. It's quite intuitive. Okay, you just have to give reasons. Let's do part A. We have to prove triangle. Let me use a highlighter. So we have to prove triangle ABC. You can also color it in as well. See, ABC is congruent to triangle, the blue one. Okay, so prove these 2 triangles are the same. So highlight it. Very good, like this. So prove the yellow congruent to the blue. Now give 3 reasons. What 3 reasons do we give? I obviously start with the obvious one. So I start with Julia. Which one are equal? AC. Yep. What do you say? AC is common. Yes. Good. All right. Let me ask another person. Lisa. The question is, give me two things that are equal in these two triangles. Yep. Reason. Yep. But you can't say it says on the diagram. Just say given. Yep. Keyword is given. So anything that says on the diagram or given in the question, you say given. That's enough. Good. We've got one more. Let me pick another person. Ruby. Yeah. Yeah. Actually, we'll start with BC because I start with AB on the left side. See, AB is here. I will start with BC. So BC equal to AD. That's given. Okay, we've got. Now that's okay, but we'll just prefer to do it this way. It's not incorrect to do that, but it's better to say if I start with AB on the left, I prefer to have BC on the left again. Okay, now we can write a conclusion. Therefore, triangle ABC is congruent to triangle CDA. Give a test. Jeremy, what test should we use? SSS, perfect. All right. What's the first line? AC is common. That's right. So therefore, I changed the rule. It's 4 lines. Yeah. Okay. You don't need to write the first line. I think it's a waste of. No, I just need these 3 and that. This is what you need. Okay. Okay, part B. That part is a little bit more difficult. We'll try to prove 2 sides being parallel. Let's highlight where the parallel. So we've got the AD and the BC. You have to show they are parallel. Now, what are the tests to show lines are parallel to each other? How do I show if 2 lines are parallel? What are the tests? Alternate angles are equal, corresponding angles are equal, or co-interior angles are supplementary. Okay, let's find the alternate angles on this diagram. Where's the alternate angles? Which 2 are alternate for the 2 red lines? Yep, DAC and BCA. So angle DAC is equal to angle ACB, but you have to give a reason. You can't say alternate angles of parallel lines because they are not parallel yet. We are proving they are parallel. So why are they equal? Now have a look. They are opposite to the equal sides. So what makes these 2 angles? They must be matching angles in congruent triangles. That's the reason you give, like the one we did before. Matching angles in congruent triangles. Congruent triangles. And why are they matching angles? Because they are opposite to the matching sides. Can you see? The 2 sides are equal. They are opposite to the matching angles. That's why I know they must be matching angles. And because they are equal, then you say, therefore, AD is parallel to BC. And the reason is alternate angles are equal. So that's the reason. Alternate angles are equal. Right? Because we proved these 2 are equal. And these 2 are alternate angles. I think that's all. That's all you do. So can you see how we use congruent test to prove a second result? That's very common in exam. They ask you to prove things are congruent. And then in part B, prove they are parallel. Or prove it bisect. Or prove whatever. Or prove it's isosceles. So that's what you have to do. Prove the matching angles are equal. Or prove the matching sides are equal. Okay, so we'll do exercise 4.4 today. You can start now. Is there anything here I could show you? No? Okay, good. All right, start now. Thank you.